All right. So previously, what we covered is the first one we had about like the basics of SQL Server, the data types. We covered normalization, selects, and joins and how they work, basic expressions, and then grouping and aggregation. Very last one. Very last session, we looked at views, used defined functions, and started looking at stored procedures. Okay, and then that happened to me, and it all went to shit. So today we're going to basically pick up the stored procedures and going to look at them a little bit more. Look at the schema allocation and protecting your basically database using schemas. Then we're going to look at user-defined table types, which is really useful as table parameters into stored procedures. Look at merge function, which is again very useful when you're using when you need to update or insert a batch of information into table and outputs out of those fields basically. So that's going to be pretty much we've got another lesson to cover triggers in SQL Server, and as the SQL Server goes, we're probably gonna stop it there and gonna start looking at the client side from a C# perspective, just the WinForms first, and then we're gonna move on to services, and then hopefully we'll have another lesson on SQL Server, but more of the architectural stuff. So we're just basically gonna decompile SQL Server database engine and see what's exactly happening in terms of the processes. But in terms of the user, day-to-day use of SQL Server, that's going to be pretty much it. So just two more left. Okay, so, and then it's dot again. Okay, so let's come back to our database. So on the last lesson, do you remember we created the store procedure, get product data by color, and then does anybody remember why is it a good idea to use store procedures in our database schemas when we actually just work with data? What's the benefit of using a store procedure against just specifying a code like this in my client application, for example? That's correct. You just need to change it in one place. Any other benefits?
More efficient in the long term because it will save the plan as such.
Yeah, basically stored procedures get compiled into, well, first of all, the execution plan is known. Okay, it does recompute that execution plan on a regular basis when you execute stored procedures because the table context changes as well. But generally, the execution plan remains the same. Then also the code that is in SQL statements like this, SQL Server has to, what does it need to do with this? Does it actually know the command update or select? Exactly. So it needs to interpret that into, do you remember what it is that we were talking about? The predicates and stuff like this. What is it called? Yeah, first predicate logic. So SQL Server doesn't have the language. It doesn't understand basically SQL as such. Everything gets interpreted into the logic that SQL Server can understand, so it can then interpret that into like commands that it can create execution plans. So remember when we look at the execution, the actual execution plans, what we see there is table scans and predicates and all that kind of stuff. This is what SQL Server interprets all those commands that we're giving it into. So basically, it does take a little time for SQL Server to take this code and basically interpret that. Especially if that code is quite difficult, or if you have a very complicated SQL statement, it might take like 20 milliseconds for it to compile it. But that 20 milliseconds, if you start executing that code like every second, it kind of adds up. So with stored procedure, it's all already compiled. The execution plan is generally well known. If the table table data hasn't changed much, it's just going to reuse exactly the same one. So there's a benefit like that. Another benefit that you might think of, stored procedure. Anybody?
This is usually a security issue as well.
Exactly, yes. One of the primary reasons why people use stored procedures is not because of the, well, okay, yes, it's a code redundancy, yes, so that we can, keep all the code in one place and everything is in one place on the server. There's a problem with version control on SQL Server if you use stored procedures. Can you imagine basically we have one stored procedure, somebody goes and changes that, and makes a mistake, and everything fails. So there's that problem, isn't it? It's a downside of it. But generally, we use stored procedures for security reasons. Okay, for example, in Linux, for example, specifically, we don't use that for security reasons. We just use it for the sake of code redundancy and performance as well. But in general sense, most of the use of stored procedures reside within splitting the stored procedures into so-called schemas, and then giving each user a schema under which they work, and only certain stored procedures they can execute, and only certain stored procedures they can see the results of, or they can see results of specific views out of those stored procedures, based on whatever schema they allocate. So it's like a department, and that department can only do things that they basically own or have access to. Okay, so let's start by basically, what are we going to start with? Yeah, let's write another store procedure. We're just going to abandon this one. Basically, as you remember, this one was for selecting data. And we had some procedural code that was going and selecting some data from product table, but it was doing it in a very in a procedural manner, such as we were creating a temp table and then populating that temp table with some select parameters. Actually, we were just basically aggregating data first there. And then we were inserting that data into the temp table, and then from that temp table we were updating that again with some further values, and then finally basically selecting some data out of it. The reason why we kind of would choose to do a procedural code within store procedure or within any kind of code is so that we can split up what's actually happening for debugging purposes, and so that we can stop or basically throttle that query if we need to. Of course, all this, any DBA would go, horrible, 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 it's a procedural code, let's put it in one big giant SQL statement so that only I can understand it, and I will never lose my job, this kind of stuff. Well, yeah, it kind of better to keep everything in one SQL statement, but on the other hand, there's also a downside of it. First of all, nobody can bloody understand what it actually does. Nobody can debug it. Something happens inside it. It's like a little black box. The bigger it becomes, the more of a black box it becomes. And thirdly, if the execution plan goes wrong for the whole thing will just basically grind to a halt and might actually, halt your server as well. There will be a deadlock transaction somewhere sitting on the server and just never finishes and basically harming the server. Where you split them into several bits, then those several bits actually execute in that manner, and therefore there's a less chance of it going wrong. Also, if you look at the SQL Server, what is it called? Like every time you execute something, again, I think we will actually look at from DBA point of view. We'll look at those things as well. We can actually look at what SQL Server is doing at any given point in time. So which user is running which SQL statement, what table are they locking, all this kind of stuff. So if something, like for example, we started the store procedure, and they just got one giant SQL statement in that basically request that we pull out who's actually running what, we'll just see that SQL statement. We're not going to see exactly what's locking up. If we break it down, then we can see exactly what's locking up. Basically, we can debug it on that level. So procedural code is slower, and it's also more kind of IO hungry, especially in this case where we insert data into temp tables. But it's easier to work with. Okay, so enough of talking, let's actually start writing some code. What I'm going to do, I'm just going to grab, instead of just typing stuff in, I'm just going to grab that, what I've had before, and I'm just going to walk you through it. So remember how we start writing the store procedures for debugging sake. Instead of creating a store procedure first and then writing some code and without being able to execute it, we just write everything as TS, TSQL statements, so procedural code, and then declare all the parameters of your store procedures at the top here, and then just start actually writing your code. So by looking at this code, can anybody tell me what is it going to be actually doing?
Is it getting the orders by due date? So an order, or I'm guessing.
Well, there's a clue there, and there, and there. Okay, so effectively, we're gonna create a store procedure where we're gonna give a product ID that we want to create there you go, a work order for. Okay, and we're gonna give how many products we want to create a work order for. By the way, for those who just joined this, we're not working with LinWorks database, we're working with AdventureWorks database. AdventureWorks is like a generic training database, so you can learn. I mean, it's got lots of data pre-populated, it's got fairly good schema, although there are bugs in that database specifically created so that you can, when you try to run something, it fails. It's so that you can follow the Microsoft certification book, which is but yeah, and it does have little traps in there. So we're just following that. We're not following exactly what the book says because I think it's really kind of daft and boring, or sometimes it's a little bit unnecessary, the stuff that they talk about. I mean, from our perspective, we're just interested in what we need to know to do our job better. So so that's what we're doing. We're doing everything like against AdventureWorks database. Basically, this specific store procedure that I want to write is I just want to give the store procedure, because that store procedure will have some logic into it. And that logic would be, if I already have a work order for this product and the due dates, basically the due date is less than what I need it to be, so we can get that work order processed quickly, and the start date is more than I specified to begin with. For example, I said I need that product to start being delivered or start being manufactured on, let's say, 1st of November, but we already have a work order that is going to start sort of in 29th of October, for example, where it was 15th of November. Then I can just place this product into that work order instead of creating a new work order. So there's a little bit of logic. So instead of actually creating a new work order, I'm just going to update the existing one. I'm just going to add the requested order quantity into that product, into that work order instead of creating a new one. Okay, so first of all, we have a little bit of logic that goes and finds the work order that we need to add the products to. If it exists, well, actually, if it doesn't exist, then we'll create a new one. And if it does exist, we're just going to add those product quantity into it. Okay, so as you can see, we could just have this SQL statement in our code, but it will be like what else is. You know, we can wrap it around the method. Of course, we can have like a business logic data adapter for this, but let's keep it on the server. Okay, and so we now have this code. I can run it, and I can see that it's working. I can change some parameters while I'm at it, just to see that it's still working correctly. And then when I'm ready, basically what I'm going to do is I'm going to change this bit into create procedure. Then that's going to be our parameters. And then what I would recommend you do when you create store procedure is to give them some kind of contextual, contextual name, so that the store procedure actually means something to those people who look at it, look at the database schema for the first time. And what I quite like doing is my personal kind of opinion is like give the store procedure the name of the primary table it's working with. For example, work order, and then after that, give it what it actually does with it, add or update, and then what, for example. So here we can very quickly see that it's related to a work order table, and it adds or updates products to it. Okay. Then that's going to be our parameters, and we're going to insert some. It's going to be our code. So if I create a store procedure now, to remember those values that I'm specifying after declaring a variable or parameter is going to be a default value. So we want to get rid of them. So the user would have to specify those values when they are trying to execute the store procedure. Okay, so we now have store procedure, and we can see it in our list of store procedures. There you go. Work order, add, update products. Cool. Now we can go and execute it by typing exec, then store procedure. Then what we can do is this, saves you time. You just can basically drag the parameters into the window and just insert all of them. Or there's a lazier way of doing things, like for example, right click, let's create script for execute, and it gives you all the parameters that you need, and it gives you the store procedure name, and then you can just basically populate them with some values. Like for example, I need product ID to be 108, 10, and then some dates. What else is RC? RC is a result of a store procedure. I think result of a store procedure can be 1 or 0. So basically, by default, my store procedure will always return 1, but I can return 0 for some reason, like for example, success or not success. Okay. All right. Okay, so yes, this is one of the traps that I was talking about in the adventure database. We can't actually update any data in the work order table because they've specifically, I think they've specifically done this. I hope that it wasn't a bug, but basically in the work order table they have made a little boo-boo. That's fine. So they just basically created one of the triggers on the table. A trigger we're going to cover in the next lesson, but in a nutshell, a trigger is something that gets fired when something in the table changes. So specifically, there's a trigger in this table that tracks any changes in the work order and then keeps the order trail from it. So they made, there's a mistake and there's a bug in that trigger which is trying to insert data into a transaction history with null values. Okay, so we're going to execute this query and it's all good. And basically, anybody with a DB owner rights on this database can just go and execute it. They can see the contents of this database. They can see all the tables, etc. But what we want to do is we want to create a user that can only do certain things in a database. So, for example, we created a win flop. We created an application, a client application that is working with that database, and we want to restrict what that user is able to do. But we want to restrict it on not only client code side of things. We want to actually restrict it from a database perspective. so that even when somebody knows the password and the login to the database for that client application, for that user, they go in, and the only thing they can do is just to view the data that they're allowed to view, or they can modify the data that they're allowed to view. Also, there's a way to control it on a much deeper level, like we do in ADM. So first of all, we protect everything with schemas, but also we protect everything with the password. So for example, instead of having a specific user on SQL Server that is allocated to specific data, very well, specific schemas, we control the users on the client side. So we create a user and write that user in a table called users. And then every time we need to do something that, for example, create a customer or delete a customer. When we delete a customer, the user, the client application will have to send the hashed password of the user. And we compare that hashed password with the user table to make sure that somebody didn't just steal the ADM database using and password details and just logged into our server somehow, and then try to execute the store procedures. Even if they try to execute the store procedures, they still need a hashed key of a hashed password of a user who's trying to do that. Okay, so and this is why we use store procedures so much in the database that we need to protect. Right, so what we're going to do now is we're going to create exactly that scenario. Well, not exactly that scenario. We're going to create a schema. I'm going to call this schema production exec. Okay, so that's going to be all the users that can work with any kind of production type tables or data within AdventureWorks database. They're going to be allocated to production exec store procedures. Well, store procedures schema. So first of all, I'm going to create a schema. Secondly, I'm going to create a user login in the database itself. So create login, user product exec, just an example one, to be honest. That's going to be our password. Okay. So create that user. Now we can see in security and the logins, we should be able to see there's a new user. Also in our database AdventureWorks, is that program? No, under security, we'll have schemas, and in there we'll have production exec schema. Now, if I try to log in with that user now, will I be able to get in? Anybody? I've been able to get in, no problem. Huh? No, check policy basically makes sure that we don't have to. There's no password policy on it, meaning that I can specify weak passwords. Like for example, my password could be 123. If I have it as on, the SQL server wouldn't allow me to create a password 123. It would have to be complex one. Also, it would have to change every 60 days and things like that. Okay, so coming back is pretty much maybe the first lesson. Remember, we have to create a login first. So the login is how the user actually connects to the SQL server, how the SQL server authenticates that user. And then we have to create a user on each database. So we have to add this login as to a user list of every single database. So at the moment, I'm logged into that SQL server as this user. And if I try to go into AdventureWorks and say, knock this off, you're not a user of this database. Although you can see it, you can see the fact that that database exists, you can't actually do anything with it. Okay? So let's disconnect, and so that's what I need to do. I need to actually use AdventureWorks database, and then just run something like this, create a statement, create user, and then name of the user that I want to be in my database. I can actually name it something different. And then what login is going to be associated with that user. Okay. So there you go. Just created that again, and if I try to reconnect again, there you go, connected. database. I can now select that database. Although I'm assigned as a user to that database, I can't actually see anything in this database. No store procedures. I can't see any tables. If I try to do anything like select from a specific table, if I try to run any SQL statement, it's going to fail saying you don't have permissions to do anything. In fact, it doesn't even see the schema of this database. The SQL server doesn't give any information about this database to the user in the first place, apart from some internal system views. Okay, although I have access to this internal yes, for example, I have access to this view called information schema tables, which actually supposed to give me the list of all the tables and all the contents, etc. of the database. This is a system view. I can see it, but if I try to execute it, I get nothing. Okay. Okay. So what I need to do is effectively to give this user that I've just created some permissions. And permissions could be a DB reader, for example. If I'm a DB reader, I can guess what can I do? I can be a DB writer, I can be a DB admin, or DB owner. DB owner meaning that I actually own the database. So I can create objects, I can delete them, you can do whatever hell I like in there. If I'm a DB reader, of course, I'll just read data. I can be a DB exec. Exec meaning that I can just execute objects. So I can execute a view, I can execute all the store procedures, I can even look at the code of that store procedure. But what we want to do is we want to actually simplify. The reason why we use schemas is to simplify the way we manage those permissions. Because what I can do is actually I can go into this user, just to demonstrate. Where is that user? Okay, I'm using the user interface because writing all that stuff in SQL or in TSQL would be a bit pain in the ass, especially for the demonstration purposes. The securables. Is it even a word? Securables.
It is now.
It is now. Yes, it's an SQL server. It must be true. Okay, so in securables search, and I'm going to add a specific object to that. For example, let's say show me a tables. And I want this user to be able to access this table. Okay, and from this table, I will allow this user to select and insert data into it. Why not? Okay, so now if I connect as that user, and then if I look at the tables, you can see I can see one table. If I try to update anything or delete anything, for example, delete from this table, go. It's down. You know, first off, we don't have permissions to do that, but I can select from it. Okay, SQL permission sets are going to quite an insane level, so that you can actually create a view, and in that view you can define which column this user is able to see, and which column is able to modify. But that's, as you can see, basically on a management, from a management perspective, is a real pain in the ass to manage this kind of stuff. So, for example, one of the easiest way to kill all those permissions is to back up this database and then restore it. All those permissions are going to be lost, especially if I'm restoring this to another server, not within the same server. So I would have to maintain that permission set somewhere. It's quite difficult to do. That's why the schemas are quite an important concept in a SQL server. It allows us to break down the database into like departments, and then give user like a department saying you sit in here, so you can do all this kind of stuff. Okay, so what I'm going to do is this user that I've created, I'm going to give him exec rights on my schema. So first of all, let me just go to that user again, into the properties, and I'm delete this securable from there. So I'm just going to untick those. Okay. Let's have a look at it again. So we've got no objects available to this user at the moment. what I'm going to do is I'm going to grant execute on specific schema, on schema production exec to this user. Execute meaning that I can execute everything that has been created with production exec schema. So all the objects that are assigned to production exec schema, this user would be able to execute. And now, if we look at this properties of this user under securables, we have product exec. It's a schema, and we have a granted access by DBO execute. The stack of the permissions, it's called permission stack, I think. It's basically what inherits from what. In SQL Server, it's basically the stack is religiously kind of followed. So, for example, if I'm a DBO and I created a table, I created a view, and that view owned by me, and I'm allowed to kind of execute it. Then, if I then create a schema and then I grant access to some other user, so all that kind of trail of all the permissions, who I granted what and what I own, kind of remains in SQL Server. So, for example, the idea is that if I created a production exec schema and it's assigned to me as an owner, then everything that that schema basically owned, well, or everything that I own, that schema can access effectively. It's quite an important concept once you start working with schemas. And you've got multiple schemas, multiple owners of the database, or multiple kind of like segments of the database. Then what you can kind of, the pitfall you might fall into is when somebody created a table and assigned to one schema, and then the other one is created like a stored procedure that accesses that database table. There's a permission issue there because there's like a conflict of ownership in there. But that doesn't really matter. It's just basically so that you can that DBO or the owner of the schema or the owner of the object, so that it starts making sense to you. Just remember about the stack. The permission stack in SQL Server. Right. All right. So what I'm going to do now is I want to take this, not this trigger. I don't want this trigger. I already fixed it. Don't want this. Don't want this. Okay. This store procedure that we wrote. What I want to do is I want to actually, well, first of all, I'm going to delete it so we don't have one exactly like this in our system. And I want to assign this, well, we create this object, but now I want to assign it to this production exec schema. And the way I do that is by, when I create a store procedure, put the name of the schema first. This is why we normally see, when we see all the tables, we see the schema name, DBO, dot the name of the store procedure, and then, for example, in tables, we see exactly the same thing. Like in AdventureWorks, there's already multiple schemas like person, human resources, production, and so on. So we're going to create the store procedure as production exec. The name is going to be exactly the same. And now, if we look at our database as a user that we have created, on the tables we see nothing. On the programmability, we see that store procedure. Now, as a user, I can't even modify it. I can't see what's inside it. I don't see any other objects in the database. But what I can do is I can execute this store procedure. So I can fire up code, and it will do the inserts, update, select, etc. So that store procedure itself has got access to all the objects that DBO owns, so they can access all of them. But as far as the user is concerned, the only thing that he can do is just basically execute that store procedure. And to demonstrate that we can actually execute it, I just delete this stuff. What? Am I being retarded? Oh yes, I am being retarded. Couldn't find the new query button. Okay, now being logged in as that user, I can execute it. Cool. So that's basically the basics of how the schema works. You know, researcher can also start. Now the next thing that I wanted to cover is user-defined tables, user-defined table types. There you go. Right. So if we come back to our original query, regional stored procedure that we wrote, you'll notice that it's a little bit no, this one. Okay, so imagine I needed to insert like 1,000 product IDs into my work order. What I would have to do is I would have to actually execute this stored procedure 1,000 times. Every time I execute a stored procedure, I create a connection, create a session, I execute it, I get results back, blah, 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 the service, and it gets redeployed. So it's much easier to compile 1,000 product IDs on the client side and then throw them all into the SQL server, and that thing will do it. That stored procedure will get executed only once. So the way we can, but here we can only have one parameter per request. So the way around this is to use so-called table-defined types. User-defined types that is a table. Okay, something like that. We'll find out what they actually called in 1 second because they're stored in here. So basically, programmability types, and we've got user-defined table types. That's what they're called. What I'm going to do is I'm going to create a schema, if I remember how to do this. No, I can't. I think it's create type. Create type. I'm going to figure out. This is going to be our type, and then I think it's just like this. Product ID int, and then quantity int. Unstable. Unstable. Cool. Right. So what I've done here is almost like created a table, right? But this is actually I created instead of a table, I created a type. So this type is basically it's like a variable that can be a table. Yes, right, it's a variable that is a table effectively. It's like a structure of the variable of the table effectively. Yes. All right. So we created that type now, and what we can do, we can actually start using that type in our stored procedure. So let's create a new stored procedure. I'm going to call it work order. Then what I'm going to do, I'm going to add or update product. But here I'm going to say it's bulk because it is. And where's my parameters? It's going to be my 2 parameters. Well, 3 parameters. And I don't have product ID parameter because I'm not actually specifying a product ID individually for every single request. I'm going to specify that there's going to be product. Hang on a second. I'm just going to, product quantity list. And that's going to be that's going to be our product type. Come on. Read only, I think. I have to specify that it's going to be read only, and there's going to be a variable. And for the time being, what I'm going to do within that stored procedure, I'm just going to select some data out of it. Cool. So what we can do now is we can actually Yes. So we can declare a variable when we're actually trying to execute the store procedure. We can declare a variable as that table, and then we can simply insert into that variable some values. Because we declared what that type as a table, it knows what the structure of that table should be, what columns I need, etc. And then I can basically execute that store procedure that just created. There you go, some parameters. And that can be our product list type. So in that store procedure, I just basically specified some normal called scalar parameters and one parameter that is actually acting as a table. So on the client side, I can go and create a table that contains all of those like 1,000 products. Just can basically insert all that stuff into a table, effectively create a query that basically just puts all of them into that table, send it as a parameter in SQL Server, and then I'll do a lot of things. All right. So okay. So imagine I want to basically complete this query. At the moment, all I'm doing is I'm just getting that parameter and just spitting that back out. But what I want to do is I actually want to go and update or insert the products into the work order if they don't exist, etc. So obviously, I can't use exactly the same stuff that I used to have up here, because here I'm actually selecting individually. I'm selecting one product. Seeing if there's a work order for it, then update it, if not, insert it. I can create multiple SQL statements where I'm first updating everything that had, that have got a work order against it, then inserting everything that doesn't have. So effectively, you have like two statements. But it's tend to be a slow way of doing things in SQL. So when I'm trying to update something and then insert, basically I have to do two things at the same time. There's quite a useful, I think starting from SQL 2008, there's quite a useful command, or quite a useful interpreted command called merge. What merge does, it basically does insert or update based on whether the values, whether the values exist. So effectively, I'm going to rewrite all this into one SQL statement that performs a lot better in bulk as well, using the merge command. And to write a merge command, you take this, Control-C, and Control-V from internet, because I can't remember the syntax. Yeah, you generally go to Google, you type merge SQL, then you go to example, you pull it, and then you just insert your own stuff into it. You never remember exactly how to do this because the syntax for it is merge as target, then you specify the target SQL statement. Basically, this is the stuff that you want to. No, this is the source. Actually, target is what you insert data into or updating into. Then you selecting all the parameters that you want to use as a source, and then that becomes like a temp table within the merge thing. If you look at the execution plan, it looks really weird. And then basically on which parameters you're going to match that query to. So for example, in my case, I'm going to make sure that the product actually equals to, in work order, equals to what we actually specified. The date is pretty much exactly the same predicates I had in the first statement. And then when matched, we're going to update the target order quantity, target being work order, with target order quantity plus source order quantity. So that's what I've specified in there. And then when it's not matched, I'm going to insert one, put them in there. Okay, so that's going to be our super cool query. And now run it, it does, we can see 2 records were affected. So it inserted or updated 2 records. I'm not entirely sure which ones. So it's pretty cool that we can do this stuff, but to be honest with this, I don't know what I've inserted or what I've got back. All I've done is just basically just execute an update statement and then or insert statement. But in case a client side then needs to get the work order IDs back so they can maybe open them or just say you just created this product in this work order or you've added this product into this work order, I need to get some results back. So I just need to see exactly which rows I've inserted, which ones I've updated, etc. So for that, we actually have a very useful thing called, it's called, huh? Yes, it does called output, but I want to copy and paste. Okay, so what we can do is basically any update, any insert, or any delete, you can get the data back about what's been inserted, updated, or deleted. Okay, and we do that by putting what do you call it? Like basically, you can is it a clause? It's not a clause. You put output at the end of it to use simple English language. Because we are simple people. Okay, so as an output at the end, I'm going to put basically output inserted, everything that we inserted, work order ID, and then inserted product ID, and then what kind of action we actually taken. Did we insert one or did we update one into output temp? Okay, normally we don't need to put it in the temp table. Normally that would be sufficient enough. Then what we're going to do, we're actually going to output all this data onto the to the client as if we've done a select statement. So in our case, everything is going to appear on the screen. Let's comment that out. F5. Yes. So now it complains actually that I can't use output in my select statement because, in my insert or update statement because I have a trigger on this statement. It's like I have no idea why, but SQL Server prevents you from using output to the user if the table has got any kind of active triggers. I don't know why. Actually, it would be a good idea to research it and find out why it prevents you from doing that. There's some kind of, I'm supposed there's some kind of technical problem with doing that. So if we have a trigger, in fact, it's a really good idea to do it all the time and never just output data back to the client directly as if we've done SQL statement. It's always a good idea to create a temp table, even though it's going to take a lot more resources to generate that, because first of all, we need to create that table somewhere in our file system and then dump data into it. And then insert that into the temp table. Now that will now work. And basically what we're going to see when we execute this is nothing. Why is that? Because although I did put it in the output table, I'm not selecting from it. Okay, now what we see here is the fact that we've updated this work order by adding some product quantity to it, and then for another one we also updated it. All right, wake up! Mark just fallen asleep. Cool. So that's pretty much about it. The reason why I said it's always a good idea to put it in a temp table is, imagine you have some merge routines or you've got some inserts and updates and then you output some data and then some twat goes in and puts a trigger on that table. So all your statements will then fail somewhere down the line without you realizing that they did. That's it. Any questions?
Oh, we're going to wait till the end. I've got most of it, and I still want to use it. Just to confirm, merge, is it